it's more than 1 decade. I haven't seen him, so hopefully. Okay. So yeah, I'm doing this on behalf of the Open Continuum project, which is part of EU Cloud Edge IoT, and it's the name of webinar. Okay. So I'm going to present myself, spend some time in the standardization process, then go into the core topic of the session, which is standards in the making. I will take several topics: architecture, IoT, digital twin, AI, trustworthiness, data spaces, interoperability, security. And then we have to go to a conclusion. And I propose 2 roadmaps, one for the computing continuum, which is actually what Nemo is doing, and data space, which is we're all doing. Okay. So first of all, myself, I'm the CEO of Trilog. We are working on IoT systems. In the past, we're saying embedded systems. We've been working on smart meters. The French Linky smart meter technology for interoperability comes from us. We are leading vehicle charging protocols, testing tools, and things like that. We work on connected vehicles. Okay. Myself, I'm involved in many ISO standardization bodies, mostly ISO IEC, and I have to apologize. I'm going to focus much more on that than others, but I'm also involved with others. Okay, and I'm working in many topics. That's why I can provide to you some insight about those topics. I'm not going to treat the metaverse, even though I'm working on that, because I don't think we have the time, but maybe in a future session. Okay. And of course, those are, let's say, technology-oriented, I'm going to call them horizontal topics, but we also have vertical topics: smart cities, automotive, health, energy, vehicle charging. And this is where I'm involved and some of my colleagues are involved. Okay. So the standardization process, this is a heavy machinery. It took me like 2 years to understand. And even today, now I've been working for 10 years, I don't think I understand fully. Okay. So we have a number of initiatives. Okay. ISO, IEC, ITU, I'm going to focus on that. At European level, we often call them EDO, European Standardization Development Organization. So Cenelec, ETSI. Then we have others, alliances, W3C, IEEE, IETF, OASIS, OMG, and the like. Okay. So they are competing. They are sometimes working together. So it's an ecosystem, and everything is open. You can decide to submit a standard in ITU versus ISO and so forth. Each one has his stress. From the IETF, IEEE on Wi-Fi, they have the stress. Well, of course, the W3C on everything related to the World Wide Web. Okay. So I want to show to you how we can be involved, and I took my own example. So here you have a number of committees, okay, such as system software engineering, digital twin, AI, trustworthiness, road vehicle, cybersecurity, privacy. I'm involved with all of them, plus some which are actually European. So, for instance, Cenelec on AI and security privacy. How are we involved? Okay, so the first thing is you go through your national body. So in my case, I'm French, AFNOR, and then I registered, and I'm, let's say, a member of those things. Okay, you see that I'm not a member from the French national body to this one. Okay, but still I'm participating. So how do I do this? So there is another scheme, which is what we call liaison. Okay, and here I show 4 liaisons which I'm using. Okay, one is AIoTI liaison. It's this one is very strong with SC41. Then BDVA has a liaison with AI. By the way, BDVA also has a liaison with this one. Okay, and then we have projects. Okay, European projects. European projects, they're entitled to have liaison. The reason is because it's a consortium that has a consortium agreement. So there's a legal existence. And the Commission has negotiated mostly with, I think, JTC1, the fact that European projects can have liaison. Okay. So, for instance, the first standards on privacy engineering came from this project, which I was leading. Okay, and so forth. Okay. There are many projects, European projects, that take advantage of this approach. So you do not need to be a member of the national body. You just go through the liaison, okay? The commission itself is sometimes supervising, like here, but sometimes they have direct link to standardization. So for instance, the EC has a liaison category. Well, I'm not going to, there are categories of liaison, but they have a liaison with JTC1, a liaison with SC42, and I think probably a liaison with the biometric stuff, okay? So, but this is not complete. You have another liaison, which are internal liaisons. So for instance, SC41 can create a liaison SC7, which is my case. So actually I have two ways to work here, okay? And particular SC41 has a liaison with working group 13. So I can follow the standards here, not through the French national body, but through this, okay? So I'm mentioning this to you because there might be many opportunities, in particular European projects, they can go into that kind of things, okay? So here is a list of involvement where I'm involved. So here I only list some of the standards in which I'm working, and mostly I'm editor. And when you see a tick, it means that this has been published. And when you don't see a tick, it's ongoing, okay? So the point is that like half of the standards are in the making, so you do not know them. So in order to know them, you have to follow them, okay? And sometimes, since they are taking 2 or 3 years, they can come by surprise to the industry, which is not following. But of course, all the big companies are following. And I would say that all the startup and small companies, they should also follow because of the previous tools we have, liaison and things like that, okay? So now, when it comes to ISO, you have these links that are available. So I'm going to show to you a number of examples. So sorry, I'm going to do that directly here. So first of all, I prepared, so let me get rid of this, I think, sorry, I'm going to get rid of my bookmark, just to get more space, okay. So you have a website here, which is the history of JTC1, so you can have a look. I'm not going to it, but it's a huge history, okay? So I just want to show to you the main page, okay, which is this one, okay? JTC1 Information Technology, okay? Well, 4,000 standards, okay? If you count this and this. And then you have the structure. So it's per committee, and you can see, so I'm going to show my favorite one. So SC27, which is information security, cybersecurity, privacy protection. So the recent one, SC41, Internet of Things, and digital twin. SC42, artificial intelligence. This was created like 2 years ago, brain-computer interfaces. And they are talking about SC44, smart cities, which is not yet agreed, but there are some exceptions. So you see here, there is working group 11, smart city, which is working on those standards, and they will transform the working group into a committee, okay? So in parallel to that, you have liaison. So exactly what I mentioned. So they have lots of internal liaison. I'm going to skip that, but you can see, so you have many, you see that the European Commission has a liaison with JTC1, okay? And actually, they follow quite seriously because they know impact is through standards in particular, okay? So I want to show to you the example of SC27, okay, which is a big one, probably the most successful committee, where they have much less standards, like about 300, and one of them is 27001, which is by far the best seller. It sells all the time, and maybe ISO is making his business out of this standard, okay? So there are, okay, I would say a top 10 standards, like in general, it's related to quality management organization aspect, like ISO 9000, ISO 27000, okay? So here again, it's structured into working group, okay? I want to show to you the liaison because this is interesting. When it comes to cybersecurity, there are lots of liaisons. So you have internal liaison, okay? And then you have here the liaison with external organizations. So you might recognize some of them. Cloud Security Alliance, ENISA, ETSI, or ETSI is IEEE, IQNet, ISACA, ITU, and things like that. And the World Economic Forum, you see here, okay? So, oh, by the way, small business standards in Brussels, okay? So you have then the category C, which are more focused, okay? And you have many European projects. ABC for Trust is a project, it was a project that started like 7 years ago, okay? Credential, you have Cybersecurity for Europe, FinTech, you have Infinitech on FinTech, you have, so let's see. Pick your crypto, prepare, Prisma Cloud, and things like that, okay? So the good thing about them is, for instance, prepare, I was the leader. The projects completed in 2016. We're still having the liaison because the consortium agreement is not dead. So we use it, and I'm using it to have members working on standards, okay? So that's what I wanted to show, okay? So if you get more into the details, so you click actually, so you click into, so I showed to you, if you click into standards, you click here, you will get this page, okay? And you have the list of standards, including those who are under development, okay? And they are sorted, so if you know the number, you know, okay? So I'm going to get into 20,000 series because this is my favorite, obviously, okay? And you have starting from 27550 here, all the standards related to privacy, okay? They wanted to start with 27500, but it was too late. 27500 is already used, okay? So this was the first standard. Actually, I was the editor of this one, published in 2019. And then you have 51, 53, 55, 6, and so forth, okay? So when you are interested by a project, so let's take this one first. So I can click there, okay? And you see, well, you have to buy it. Well, it's costly, okay? 187 Swiss francs, okay? So what do? We go to read sample, okay? Here, and then you have what we call online browsing platform, okay? The online browsing platform provides you some content of the standard. So it includes everything until the terms and definitions, so forward, introduction, okay, then the vocabulary, and then that's it, and then the bibliography, okay? But very importantly, on the left, you have the whole table of content. So you can have here an understanding of the content, okay? And people who do good standards, they try their best to have all the message available in the table of content, okay? This is what I did so that you know exactly the content and you see whether you're interested. Further, okay, there is an introduction. We try to explain, let's say, the rationale and things like that, okay? And of course, this is needed. I just want to show to you another one. So sorry, I'm going to get, if I can, well, actually, I need to show ISO 27570, okay? If I can, which is this one. So it's a privacy guideline for smart cities. I was also the editor. It was 2 years ago, okay? And what is important is I made sure that introduction, the whole message is there, okay? So it's an executive summary of what it is, and it gives an idea, okay? So of course, probably it's not the intent, but the goal of people doing standards is to make sure that it's accessible, okay? It's not that accessible, but if you get to the introduction, the table of content, you have many things, okay? Last but not least, you have the online browsing platform, and you can search for things. So you can search for standards, and you can search for terms, okay? So if I'm putting here IoT, okay, then you have here a number of definitions, and you can decide which one is good and which one is not good, okay? So that's the idea. I'm getting back now to my slides, okay? No, I forgot one thing, okay? So sorry. There is one other link I want to share with you, which is what we call, the publicly available standards, okay? This is a link in the slide, you will have it, and you have all the standards that are free, that are available for free, okay? There are many, so you can have a look and then decide to download the software, okay? That's what I wanted to show, okay? So I'm getting back to this, okay? So here is when you look for definition, that's what I showed to you. Browsing the standard, this is what I showed to you. And then now we get to the next stage, okay? How do we build a standard, okay? So it's, of course, a match process of a consensus. And I'm using a color convention where green means published, orange means it's it started to be agreed, but it's at the national level, and red, it's at expert level. So you start from something we call preliminary work item, where you do studies, okay? And then you have a clear idea of the content, we call it the scope, and then you start to work into what we call working draft, and those are provided by experts, okay? Then we try to agree, and we get to consensus level, where national bodies, so it will depend, but let's say the international one, ITU, ISO, IEC, they are through national bodies, okay? And then you get here, and then you get to publication. So the only exception I would say is ETSI. ETSI is, let's say, a European organization which is led by companies, and the vote is per company and also per company size, okay? Which is sometimes the reason why people would say it's not the right way to do, but I think everything is worth doing, okay? So then how do we build a standard, okay? So we have a document, and then you have a template. It's always something like this, where you put actually the title of the document you are studying, the date, and then which projects, for instance, 27550, and then you will provide the line number, clause, paragraph, type of comment, and you provide the comment. This is wrong, this is good, you make a mistake, I think. And then what is important is you have to make here a proposed change, okay? And this has to be very much actionable, because the editor must check whether it's going to be accepted or not. So he cannot make the decision alone. He can make a proposal, and then it's a consensus meeting. People say, yes, we agree, not, no, we don't agree. And then the decision is made here. And the decision is, I can implement the change, okay? If it is not done properly, and so for instance, if you say here, please improve, okay? This is going to be rejected because it's not actionable. Okay, you leave the choice to the editor to improve, but he can actually it's not his job to doing. Okay, so hopefully you understood how it's going. Also, now the point is, it's hard to understand the list of standards, and I want to show to you an initiative we started in with the help of the Commission. There was an initiative called IPEN. It's still there, Internet Privacy Engineering Network. In 2015, my company volunteered after request of IPEN to create a wiki on privacy standards, okay? So this wiki is the most widely accessed standard right now, and this is this one, okay? It's lots of content, but very small, okay? So you have here the list of standards, published standards, okay, here, standards in development, and active preliminary work item, okay? So if I'm looking, say, here, so I'm going to the one I'm working on, so you have the name of the editors, the scope, documentation, the history, and that's it, okay? So you have all of them, and people can follow them, because then you have an idea of what it is at stake and things like that. So I'll give you an example of, so this is all, I'll give you an example of a standard that is really sensitive is age assurance. So do I have it here? Yeah, here, okay. 566 age assurance, okay. This is a big standard, because you want to make sure that child doesn't access to a social network because he's saying that he's over 18 or over 21, okay, things like that, okay. So let me get back to this. So now I want to show you a conceptual model of standards. It's just huge. So I'm going to use this. So you have on the left use case standards, okay? And the use case standards, they inform all the other standards, okay? And I'm going to show you an example, okay? Then you have concept standards and process standards, okay? So they are used to build architecture standards, interoperability standards, okay? And then out of this, you can build the system. So we have a kind of architecture of standards. Okay, it's my invention, but I haven't shown it many times, and people have actually improved the picture. Okay, so when you say I have a standard, you have to wonder yourself where you are actually doing the things. Okay, and in a project you can start here because we have so many pilots. You can say, okay, I want to contribute here. Okay. And then when you have a total implementation, you can say, okay, I have architecture things, I have interoperability things, and I have system things, okay? Or process things and concepts, okay? So I want to show to you two examples of standards. One is 24030, AI use case, and one is 27563, security and privacy in AI use cases, okay? I'm the editor, I was the editor of this one, okay? So you can see I put a link here, because you will be surprised actually that 90% of the standard is available in those links, which are available for free, okay? So it's a kind of scheme that we're using. So here, okay, this one, it's actually the list, you see, 1 to 365 pages. It's 132 use cases that was collected during the work of 24030, okay? And actually, so you can see here, it's a very classical, those of you who are working on pilots, you do always the same thing. So you have a template, you just fill it out and you provide data characteristics and things like that, okay? So this one is quite nice because it's explainable AI for genomic medicine, okay? So when the security and privacy people had a look at that, they said, my God, they are not caring about security and privacy. So we came up with the other standard, which is this one, okay? And we came up with this document, which is only 168 page, but actually it looks at the 132 use cases, okay? And then the template here is actually checking this use case only from a security and privacy viewpoint, okay? And it does an assessment, okay? So something like security and privacy concerns of genomic sequence processing can be maximum, okay? And then you have a number of items we have looked like, such as privacy concern, risk, controls, assurance, plans, okay? On a different, let's say, system of interest. So you have actually here the genomic sequence processing system, and here the genomic training system, okay? So you might have several systems which are at stake, okay? And we provide a view at the end, which is a picture summarizing the impact of the use case on security privacy, and you see the red color means it's maximum, okay? So we did this, and so you can see that a use case is very interesting, first of all, to comparison, but also to detect, let's say, the priorities. So I would say security and privacy in AI is a high priority. Mm-hmm. So let me get to the next page. Yeah. See you, I think. Okay, so now I want to mention a few things about the regulation, okay? And this is very much European. So since NEMO is a European project, I think I should talk about it, okay? So we have a number of directive regulations that are worked out by the Commission, with the Parliament and the European Council. And you have, for instance, the RED Delegated Act. RED is Radio Equipment Directive. And it's about the cybersecurity of elements that are connected through Wi-Fi or through wireless communication, okay? So they do what we call a standardization request, standardization request M585. And then actually the European organization, standardization organization, must work on the standards, and they work here on 3 standards, okay? So you can have a look to this link, because you will see have this, okay? So this then will become standards that have to be used by the industry, okay? It's complicated because it's more than standards. It's standards associated with regulation, okay? So which makes the Cenelec machinery even more complicated than the others, okay? But it's working in progress, and they work really hard on that, okay? So on parallel, you have the Cyber Resilience Act. proposal of September 15th, there is already a request for standards, and there will be we will embark in a number of projects on that. Okay. Last but not least, and I'm involved in this one, is the AI Act, which you have seen on Friday was announced all over the world, where saying that Europe is taking the lead here. And this is based on that. There is a so-called standardization request, and this is the architecture. You see, you have 10 topics, well, 11, risk management, cybersecurity, transparency, and so forth, and then an overarching, which is trustworthiness. Okay, I will be a co-editor of this one. So now that I've mentioned the how do you do the process, I'm going to spend probably 20 minutes, so we leave 10 minutes for questions, okay, on the standardization in the making, okay? So I'm going to start with the most important one to me is architecture, okay? So in standardization, it's a tradition, has been working for 50 years on standards. So, and it's just reflecting the state of the art. Nothing is new in standards. It's only things that state of is doing, okay? So they made though a nuance that I want to highlight is you have an architecture and you have an architectural description, okay? So in a standard of architectural description, you might write things, but they relate to that. So we make the distinction because sometimes we need to be clear, okay? So you would see this. And the standard is 42/10. Edition 2 was published last year. And it shows, you see, the difference between architecture description and architecture, but it shows the methodology, okay? So an architecture description also explains the rationale, okay? So you have here, first of all, it explains what is the topic of interest, the intensity of interest, and then let's say the rationale. So which stakeholders have which concern and wanted which viewpoint, okay? So this is maybe even a template-based or expectation-based, okay? So you provide a description of what it is you want, and then the architecture provides the view, okay? So the architecture is here. That's it, okay? And actually, in an architecture description, you have to provide everything. You just don't provide this one, okay? The rest must be important, otherwise you don't understand, okay? So what we are doing currently is we're building a number of standards which follow exactly this rule. And we are creating what we call a reference architecture standard, which then can be used to create a solution architecture, okay? So this has to be quite generic, and we cannot prevent, let's say, innovation to invent the new features. Those new features are in what we call patterns, okay? So actually, this is a machinery. It's like a Lego brick. You have this, you build, you add a few things, and you get to something which create innovations or uniqueness and things like that, okay? So here is an example. If I'm an IoT guy, I'm going to start with IoT reference architecture, and I'm going to use patterns on digital twin, cloud, security, and create my thing, okay? But if I'm not an IoT guy, I'm a digital twin guy, I'm going to do the same, and sometimes I'm still going to add the IoT, okay? And if I'm a cloud guy, which many are, I'm going to do the same, okay? But in reality, the IoT array here will be here. The IoT array will be here. So what we say is that an IoT reference architecture is also a pattern. So there is a recursive thinking here. So you just to allow people to construct the thing according to their, let's say, priorities or their point of view, okay? So for instance, in the energy industry, many people have the digital twin vision and no longer the IoT vision, okay? So what is the roadmap for architecture, okay? We see that there are 3 steps, and this is the roadmap which ISO and the standardization IEC is trying to take, okay? When we start, it's always about blueprints, okay? You might have heard about the data space blueprint, okay? But a blueprint is actually an example of implementation that you try to generalize, okay? Once you have many blueprints, you try to capture the essence, what you call the foundations, okay? And actually you simplify the architecture because when you have the essence, you no longer need to get into all the details, okay? And then you still want to allow for, let's say, innovation, and you create a community of patterns and enablers, okay? ISO IEC are thinking about having this published dynamically, not as document, okay? So what we are doing currently in IoT is we have published edition 1, which was actually a blueprint, 2018. And then we are currently working on edition 2, which will be published early 2024, foundations, okay? And we are going to start working on edition 3 right away to create this world, okay? In parallel, we are trying to go faster. We are going to work on the digital twin reference architecture. I'm one of the co-editor, this one. Okay, so here is who in reference architecture, and this shows that it's complex because it's not only in one committee. Okay, so in reality, everything goes into some international association. So INCOSI is the one working on system engineering. Okay, and they provide all the experts of the world are here. Okay, and they provide their expertise to SC7, System Software Engineering, which has a working group dedicated to architecture. This dedicated group worked on the 3 main standards in green that are published: architecture description, architecture process, architecture evaluation. Okay, and they are currently working. They started 2 months ago on those 2, 42024, 42042, architecture fundamentals, reference architectures. Okay, so by the way, 24024, 42024 is a palindrome, 42042 is recursive. Okay, so they selected the number on purpose. But we do this not just for the beauty of doing the standard, because it's going to be used, okay? So SC38, 41, 42 already have some standards which are sort of compliant, not completely, but we bet that in the next generation they will be compliant. And in ISO, in SC41, we work on 2 standards that are matching this one, okay? Not speaking about the cybersecurity, which I think I'm going to show maybe in a few minutes. So this is architecture, okay? So I'm going to get to IoT a little bit faster. So IoT was started in 2019, but actually the committee was created in 2016, and there is a scope, okay? And we added in 2020 digital twins, okay? So here's the structure. It's very heavy. You have lots of things. You see my name here. I am chairing AG25 use case and external user collaboration. But you have here smart energy, you have power management, you have utilities, smart manufacturing, things like that, okay? So I put in green all the standards that are published, okay? And you have here the foundational interoperability application sensor network, underwater acoustic network. This is quite strong, okay? Led by, mostly by Korea, okay? And then you have standard in the making. So you have here those who are already at the national level, and here are those which are at, let's say, expert level, okay? So don't want to get into detail, otherwise we spend hours, okay? So I just want to show that you have a number of standards on interoperability, okay? You have a number of standards on architecture, okay? You have a number of standards on data and data space, okay? And that's it. So we have the same thing for AI. So by the way, those committees are working separately. So we have the danger, and the problem of silo, okay? So we need to work together, but we do not know yet at standardization level how to do it properly. So here are the standards on AI, and you can see you have foundational standards, data, trustworthiness, use case, computational approach, okay? And I'm going to show to you again the main things that I like. So here you have standards on data, okay? Here you have standards on management systems. So management system is a copy and paste of the 27001 approach. So this is going to be hugely successful. That's my bet. So because 42001, it will be the standard that everyone will use at organizational level, okay? And then you have here architecture engineering. So this is my part, a little bit neglected by those guys, but we will catch up, I tell you, okay? So then we have trustworthiness. Trustworthiness is an overall concern. And actually it started, so you have a definition, by the way, I need to express that definition is verifying the expectations. Okay, so this is the definition. And here you have again a trustworthiness related project. You can see that it's everywhere. So you have here a working group that is dealing with trustworthiness in general. AI has huge, let's say, involvement there. Cybersecurity, IoT. So, for instance, I'm the editor of this one, okay? And then you have, of course, all the things done in SC7 and some others, okay? I mentioned here, for instance, the JTC21 AI Trustworthiness Framework, which I'm working on. So, and we have another view, which is data and data space. So this one, I'm still working on it because I started a bit late. So I'm just showing actually a taxonomy of standards. So from a technical perspective, in green, what is published, in red, what is underway. So you have data technical perspective or data space, data interoperability, okay? I put here also the committee which in which it is done. Okay, so you see it's not the same. So, but for instance, SC32 is on data exchange. Okay, so you have data interoperability here. You have data interoperability at policy level. So I'm also the editor of this one. So this one is particularly important for me. Okay, because we get at the highest level interoperability. You have provenance, data sharing, okay, in particular in terms of privacy, de-identification aspect and things like that, okay, governance, okay, of the ecosystem, and then data usage, okay. And I want to highlight those three one here. So data usage terminology, data usage guidance, this is nearly under publication, it's nearly final. And this one is a Chinese standard actually to log the activities so that then you can check, you can verify that it is done properly. Okay, so it's called data security monitoring based on logging. So interoperability is another aspect, and I want to show to you what we do in IoT and digital twins. So basically, everyone knows that from data you can get to information, to knowledge, to wisdom, or sometimes we say insight. Okay, and if you take a digital twin view, you switch from this world to the upper world. Okay, and so the architecture of a digital twin typically will be something like what we see on the right. This was proposed by some Chinese researchers. Okay, so that you have data on models and you have original data, but of course they have to match. Okay, and then you have to interact. So you have interaction data. Okay, so the thing I want to highlight is because I'm part of this one on the policy and behavioral interoperability. This is to me the vision of the future for interoperability. And I'm taking the example of digital twin where you have a target entity, for instance, a vehicle, a drone, smart city system, let's say energy system, okay, smart grid system. So it will implement interaction models, so how it interacts with others. It will implement a behavior, and it will do some implementation of its behavior. So we have separated on the things, the behavior that has to be published, and the internal behavior that you do not need to publish, okay? And the digital entity or digital twin, he should be aware of the interaction model or the behavior model, and then he can interact and he can verify and validate, okay? So this is one vision that we can see for policy and behavioral interoperability. I think that was my last one. Standards in the making, so 2715, cybersecurity evaluation of complex system. I'm a co-editor of this one, okay? So again, what we see is that there is a need to express cybersecurity at the architecture level. And architecture level is high level, so you should be able to capture the essence of cybersecurity at the highest level, okay? So that we can then decide whether we are cyber secure or not. That's the idea. So the idea is the following. There is a standard called ISO 15408, common criteria, which has been used for decades, but it's very heavy, it's very complicated, and it relates to those artifacts on the right here. I don't want to get into details, but you have conformance claims, threats, objective requirements, security functional requirements, security assurance requirements, and all those things here, okay? And what we see is that nothing is said about architectural artifacts. So what we want is to highlight, to extend this with architectural artifacts. And so, of course, you need sometimes to have both, but we need to certify the architectural artifacts before we certify the rest. Because if you have certified the architecture, you don't change the architecture, then you can think incrementally in details about the leaves of the tree, okay? That's the idea. And this is how we see it. It's 27115 will provide the framework, express how we specify a profile. And a profile includes many, if not all, architecture artifacts, okay? So that the profiles then is defined. For instance, I can have a profile for a drone. I can have a profile for a vehicle, okay? And the profile can be certified. So you certify actually the architecture part of the profile. And then you can do the implementation and get to the certification of the implementation, okay? So if you separate this, this is stable, while this is more in the incremental aspect or specialization aspect, okay? So that's the vision we try to promote. I'm in touch with ENISA to mention to them this vision. Okay, conclusion. So the most important thing is I want to highlight is integration issue, okay? So you can see if I'm taking a digital twin approach, you have lots of things that can be ongoing. For instance, you have an energy aspect, and you have the regulation, some energy label, energy usage. So it's complex, okay? Okay. You have also technology maze. So the same thing, you might have functional requirements, knowledge, technology, system of system, life cycle, non-functional requirements, okay? So it's rather complex, okay? And of course, they get together, for instance, models here, they are used in simulation, they are used in semantics, in AI, and things like that, okay? So how does it translate in standardization? If I'm looking at the SC41 digital twin, we need to liaise with all those guys, okay? So, just for you to know, today it's the weakest part of standardization. This thing is done on a goodwill basis. It's not governed. So it happens or it doesn't happen, okay? So this is the challenge of the future, this integration aspect. This is another example where you provide the horizontal. So we have here a number of items you need to work on, and we need to interact with those guys. Okay. Today, the problem is we are only specialized, so we are here, here, or here. It's very rare to have someone has a global vision. Okay. So this is an example on the metaverse, which I showed to the metaverse people, that if I'm taking SC24 graphics, here they will have to interact with other committees. Okay. So my last two slides, what are the scenarios for data space and computing continuum? And I propose the following, okay? So a computing continuum, which is actually the reason why NEMO is there, the Meta OS, okay? So my suggestion is that we need to go into what I'm going to call a computing continuum reference architecture. If we have this, we'll be able to guide implementations or to provide building blocks. We could lead in Europe in providing building blocks related to that, okay? So how can we do this? That's the vision, okay? So the vision is this, okay? So we need to first of all, to work on this, to work on the taxonomy of computing continuum. And of course, task force 3 is doing it. And then we have the blueprints, okay? So, so we put them together and we provide this to standardization so that then we can build the computing continuum reference architecture and its essence, okay? I will help doing this. And of course, when you have this, you get into the enablers and patterns. And this is where Task Force 2 comes in, because you have open source. So we are building here actually things which are going to be the enablers and the patterns there. So to me, it's not sufficient to implement the enablers. You have also to push so that the enabler specification and the patterns are recognized in this thing, so that actually when people build their architecture, they can say, okay, I'm using this enabler. And by the way, there is an open source that is available, okay? So I'm talking about this on reference architecture for computing continuum. And we have the same thing for data space, exactly the same thing. So we need to get into a data space reference architecture, okay? And we need to do this, okay? So this is done elsewhere. So for instance, DSSC just published the blueprints. It has been used widely. So we have nearly the same stage here. And we have to go into a data space reference architecture and to create, again, enablers and patterns, okay? No need to say that this and the previous version here, they have to work together, because some of the computing continuum enablers will be integrated in a data space environment, okay? So that's it for me. Rotaria, back to you, and question and answers. Okay.
Thank you. Thank you, Antonio. It was really a great presentation with a lot of information. I didn't see any question in the chat. I don't know if, and still I don't see some hand raised. I actually do have a question that is in a different level of your presentation, probably because we were talking about the roadmaps for enablers. And so it means also to create some specification.
Yes.
But do we need a specific number of specification? I mean, there is a custom model for this.
So each project, to me, has to do his homework to provide his deliverables and vision of architecture. So we have, let's say, a wealth of, let's say, solutions, okay? So this is what the Commission is doing when they fund several projects doing nearly the same thing, but because we need to have that diversity. Then at some point, we need to agree on things that are actually common, okay? Without privileging, because a Commission is neutral, okay? They don't want to select one particular solution. They want to be neutral. So we need to agree on what is we believe is common. So this is what standardization is do. And then you have the ecosystem that plays role, and who is winning, we'll see the market is deciding. So that's the, I hope I answer your question, but I think basically each project does his work, and there is a space in each project where we have to work together and to go to standardization. That's why the Commission is pushing. I'm also pushing, okay? And if you have a question, just come back to me, because I can help so that you understand what it is you have to do, not as a hassle, but as a mean to go for impact, okay? This is quite important.
Okay, thank you. I saw a question in the chat. I will read this. What is the support that the RIS can expect? Yeah. But you already answered.
So yeah, I know, and Albert, I know him. So the support is provided somehow by attempts of the Commission to have supporting projects on standardization. Okay, for instance, you have standard ICT, which is funding experts that want to do something. So if one of us, I mean, a European expert working in a project wants to support something, to do something in standardization, he can get a fund, okay? So he have to learn. So there are a few, so you have HS Booster. I do not know details, but I have quite a few, okay? The only thing I have to say is that sometimes a support action, for instance, Open Continuum or EU Cloud IoT, is only 2 years. So I think it's a kind of discrepancy, because our support action should be longer than a project, okay? But the Commission will probably then go to other support actions. So the list of support action, the support action should take over the previous support action to provide those support, okay? So that we get more and more, let's say, involved or knowledgeable in standardization. That's how I think we can do, okay? And the access is also some people, I give you an example of people working on ontologies. So Spanish, so Raúl Castro was working on in research, and then he accessed the Spanish national body, UNE, he become head of delegation for Spain on IoT, okay? And now I have a friend who can vote with me on the same directions, okay, I tell you. So there are a few things that are quite interesting in doing, going through the national bodies. Okay.
Okay, we have actually another question. I think that is the opposite question. Yeah, what support can the standardization expect from RIAS?
Yeah, so the standard people, they do not invent something new. They only rely on existing implementation, existing open source, existing ideas, and proofs of concepts, pilots, and their maturity, okay? So this is the only way. It cannot be elsewhere. So what we're expecting from RIA and IAs is that they work on their concepts and they mature them. And while they mature them, they propose them to standardization, okay? And this is what standardization expects, okay? We don't want to have a standard which is at odds with the research stream, the research orientation. We just need to go the same direction. And this is really what the Commission, I guess, wants, and what I would like also to get from RIAs and IAs.
Okay. Okay. Yeah, that is clear. That is clear. So thank you for this answer. I think we don't have other questions. So I would just like to remember all that the webinar will be available online, and I would like to thank the audience for being here, and a special thank to Antonio that give us this talk.
Can I ask one last thing? So we have a SC41 plenary in Helsinki in May, and I'm currently discussing with the Commission to have a workshop where we do the promotion of the continuum. Okay, and actually I'm discussing internally with Open Continuum so that this happens, so that exactly where we said. So the standardization gets the input from the RIAs is going to happen, and then we can implement the roadmap I've just showed. Yeah.
Okay, maybe we will also circulate this information if you are subscribed to the mailing list of the task force. So okay, we will circulate this. Thank you. Thank you again, Antonio. And I really thank you all, and see you in the next webinar next year. So I take this moment also for send you a Merry Christmas.
Yeah. Okay. Merry Christmas. Happy New Year for next year.
Yes.
Merry Christmas. Bye-bye.
Thank
Bye-bye.
you.
Enjoy your holiday. Thank you. Merry Christmas.
Thank you.